Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 5 to 8, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 5. Roman has 9 cards shown below. 1, 2, 3, 4, 5, 6, 7, 8, 9. You must only use the numbers on these cards, so we can only work with these numbers, and we've got to show all our working for this question, guys. So part A, 1, calculate the sum of the two prime numbers. So we need to identify the prime numbers in this set of cards here. So remember, prime numbers only have two factors, 1 and themselves, so they don't appear in any other times tables apart from their own times tables and the 1 times tables. So to start off with, there's only one even prime number, which is 2. 2 doesn't appear in our list. So actually, any other even numbers can't be prime. So we're going to ignore even numbers and we're going to look at the odd numbers. Well, 9 is in the 3 times tables, so that can't be prime because it's in the 1s, the 9s and the 3 times tables. 13 is our first prime number. And then 14 is even, so it can't be prime. There's only one even prime number. 15 is in the 5 times tables as well as the 1 and the 5s. It's also in the 3s, so that's not prime. 17, that's another prime number. We're doing the sum, so we're adding. 24 is even, so that's not included. 27 quick spots in the 3 times tables, so that's not odd. 32 and 36 are even, so they are not prime numbers. So we're going to add these two together. So 13 plus 17, didn't write it in my calculator correctly, is 30. Okay, part 2, calculate the product of the two square numbers. Okay, so whereas sum means add, product means multiply. So we want to multiply the two square numbers together. So remember, a square number is the answer you get when you multiply a number by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So that's our first square number. We're doing the product. 4 times 4 is 16. 5 times 5 is 25. Neither of those are in here. 6 times 6 is 36. So we're doing 9 times 36. So that's 324. Part 3, find the number. So just one number, which is a factor of 72 and a multiple of 8. Okay, so factors of 72, we're going to start with those first. So factor pairs, 1 times 72. 2 times 36. If you're not sure, guys, 72 divided by 3, 3 and 24. 72 divided by 4, 4 and 18. 72 divided by 5 doesn't work. 72 divided by 6, 6 and 12. 72 divided by 7 doesn't work. 72 divided by 8, so you've got 8 and 9. 72 divided by 10, nope. 72 divided by 11, nope. And then we're back to 72 divided by 12, and we already have that. So this is all of our factors of 72. We want multiples of 8. So we want them to be in the 8 times tables. So no, 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 no. 8 is in the 8 times tables. 9 isn't, 12 isn't, 18 isn't, 24 is in the 8 times tables. Let's check these two. 36 divided by 8, nope. 72 divided by 8, that's in the 8 times tables. Do we have any of these three numbers in this list of cards? Well, we don't have the number 8. 24. We have the number 24. So that is the number that is both a factor of 72 and a multiple of 8. Part B. Roman picks one of his 9 cards at random. So he picks one card at random. He says, I have a 2 out of 9 chance of picking a card with a cube number on it. Is Roman's statement correct? Yes or no? Show how you decide. Okay, so we're going to decide what his probability of picking a card with a cube number on is before we tick a box, guys. Okay, So cube numbers. So a square number, you times it by itself twice. So 1 times 1 is 1, 2 times 2 is 4. A cube number, you times it by itself 3 times. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3. 27. 27's in this list. And then 4 times 4 times 4, 64. We've gone too high. So actually there's only one cube number in this list. So there's a 1 out of 9 chance of picking a cube number. So he's incorrect because he said there was a 2 out of 9 chance. Oscar is making a model of his house. So there's a diagram of the house. It's not drawn to scale, so we can't measure anything directly from it. He decides to use a scale of 1 centimetre represents 1/4 of a metre to make his model. Part A, his model is 30 centimetres tall. How tall is the actual house? Okay, so 1 centimetre represents 1/4 of a metre. Okay, so 1 metre is 100 centimetres. So 1/4 of a metre would be, in centimetres, 100 divided by 4. So 25 centimetres. So 1 centimetre on the diagram is 25 centimetres in real life. So we're going to convert his model height to his real life height. So I'm going to use a proportion table. If you've seen my previous videos, you know that I quite enjoy these. So centimetres, oh well, I'm going to change that actually. I'm going to go model and then real. So the model is 30 centimetres tall. We don't know what the real one is, but we know that 1 centimetre on the model is equal to 25 centimetres in real life. Okay, so we're going to scale up from here. So 1 times 30 gives me 30. So if I times by 30 on this side, so 25 times 30, so it's 750 centimetres in real life. So his actual house is 750 centimetres tall. However, I'm going to change that, guys, to metres. You don't have to, but I don't think centimetres is a reasonable thing to talk about house height in. So I'm going to say that that's 7.5 metres tall. You will get marks for either of those answers, guys. Part B. The front window of Oscar's house is 2 metres wide. How wide should the front window be on his model house? Give your answer in centimetres. Okay, so another little proportion table to organise my thinking. So model, real. So our scale is 1 to 25 from earlier. The front window of his house is 2 metres wide. So 2 metres is 200 centimetres. So in real life, we've got 200 centimetres. We want to find out how many centimetres on the model. So we're going to scale up from 25. So 200 divided by 25 is 8. So I need to multiply by 8. So when I multiply by 8 on the other side, that tells me that the window on his model should be 8 centimetres. I don't need to convert it because it's told me that it wants my answer in centimetres. Question 7. The following sequence of patterns is made using lines and circles. So pattern 1, pattern 2, pattern 3, with a mix of lines and circles. And underneath it tells us how many lines and circles for each pattern. Part A, how many lines and circles will there be in pattern 5? So we have pattern 1, pattern 2, pattern 3. We're interested in pattern 5 and we're interested in lines and circles. So I'm going to deal with the lines first. So in pattern 1 there are 6 lines. In pattern 2 there are 11 lines. In pattern 3 there are 16 lines. So I'm going to see what this sequence, because it tells us it's a sequence, is going up in. So I'm going to do 11 take away 6. So from 6 to 11 we add 5. Double check, 16 take away 11. Yeah, we've added 5 here. So I'm going to keep adding 5 till I get to the 5th pattern. So this would be the 4th, this would be the 5th. So 16 plus 5 is 21. 21 plus 5 is 26. So there will be 26 lines. I'm going to do the same with the circles now, guys. So in pattern 1, it's 5, 8, and then 11. So let's see what it's going up in. So 8 take away 5, add 3, 11 take away 8. Yep, that's 3. So we're going to add 3 till we get to that 5th pattern. So 4 and 5. So 11 plus 3. And then 14 plus 3 is 17. So there are 17 circles. Part B. Is it possible for a pattern in this sequence to have 36 lines and 24 circles? Yes or no, show how you decide. Okay, so we've got a couple of different ways we could do this, but I'm going to do it by comparing the sequences. So here we have lines, circles. So I'm going to write this sequence. So 6, 11, 16, 21, 26, and then the circles underneath. So 5, 8, 11, 14, and 17. Okay, so is it possible to have 36 lines and 24 circles? No, it's not, and I'm going to tell you why, guys. This is an even number of lines, so if we have a look at everywhere we have an even number of lines, let's look at what the corresponding number of circles is. Well, actually, the corresponding number of circles are odd values. So if there's an even number of lines, we have an odd number of circles. If there's an odd number of lines, we have an even number of circles. So I'm going to say, no, it's not possible because 36 and 24 are even. And then I'm going to say a little bit, when the lines are even, the circles are odd. Question 8a. A head teacher wants to put a new carpet in one of his classrooms. He uses carpet that costs £12.48 per metre squared. The diagram below shows the dimensions of the classroom. So it's a rectangular classroom and it's 8.5 metres by 5.5 metres. The diagram's not drawn to scale, so we can't measure anything directly from it. How much will it cost to buy the exact amount of carpet needed to cover the classroom? So whenever we get any questions that are dealing with carpet, flooring, grass for a garden, soil, that kind of thing, we're dealing with area because we're dealing with filling in the space inside the shape. So we need to first of all find out the area of the classroom. Okay, so the area of the classroom, it's a rectangle, so we do length times width. So 8.5 multiplied by 5.5. So that's 46.75 metres squared. Now each one of those metres squared costs £12.48 because it's £12.48 per metre squared of carpet. So we're going to multiply this by £12.48 to find our total cost. So 583.44. So it costs £583.44 to buy the carpet that covers the classroom. Part B. The head teacher needs to buy vinyl flooring for a different classroom with an area of 67.2 metres squared. It's sold in rolls that each cover an area of 10.5 metres squared. What is the minimum number of rolls of flooring he needs to buy? Okay, so the area is 67.2 metres squared. Each roll covers 10.5 metres squared. So we're going to see how many 10.5 metres squared we have. So we're going to divide 67.2 divided by 10.5. So that's 6.4. So we're going to need 6.4 rolls. We can't buy 0.4 of a roll, guys. So we're going to have to buy 7 rolls to make sure we have enough.